Hi everyone, how are we doing? All good? Thanks for thanks for being here today. It's I've been trying to get into this conference for about 5 years, I guess. So today is finally the day. I'm here with you in Norway, and well, I would love to welcome you in Norwegian. Who's Norwegian here? Norwegians. I can't speak Norwegian. I can do a little bit of Swedish, apparently. And from I have a lot of Swedish and Norwegian colleagues, and apparently, if you speak Svorsk, which is a mixture of the Swedes speak Swedish and the Norwegians speak Norwegians, that conversation goes flawlessly. So let's see if that goes. So if I would say in Swedish, Välkommen, jag heter Thijs, jag är teknisk evangelist på Varnish software, men idag ska jag inte presentera på svenska, men på engelska, that would make sense to the Norwegians, right? All right, good. Now there's a little bit more pleasantries to go through before we can actually get to the heart of this presentation. So what I want to do is I want to present you 3 distinct statements of the topic we're going to talk about. I'm going to keep it quite general. We'll talk about web acceleration and the impacts of that. And I've done this a bunch of times today. I think it's my 340th. I keep track of all of them. And I do it through 3 distinct statements. And the setup isn't ideal, but let's try to do some crowd participation if we can, right? Because this is a really interesting and big venue, now for those who are watching this from home, I'm on a suspended stage across an arena, and we have arena seats here. So let's try this, okay? So people here at NDC, I'm not sure if we're going to hear you back there, but are you ready for this? Okay, not bad. Let's try one more time. Are we ready for this? Wonderful. So, do we agree that slow websites suck? Okay, wonderful. That's 1 out of 3. That's just to make sure we're on the same page. So we got that out of the way. Let's start with number 2. Do we agree that web performance is an essential part of the user experience? Yes? Okay, good. 2 out of 3. Here's the controversial one. The one that usually doesn't get a yes or no reaction, but usually a meh reaction. Do we agree that a slow website is just as bad as a website that is down? See, meh, yeah, maybe so. Now, regardless of your opinion, here are the facts. And your facts, unfortunately, don't care about your opinion. If your website is slow or your website is down, you will lose money. You will lose face. And you might even lose a bit of that Google PageRank you are so craving for. So that's the situation. How do we resolve it? Well, there's a variety of ways of tackling this. Let's start at a very symptomatic type of behavior. What we could do is throw servers at the problem. So if your website is slow, a lot of people think, well, if we're slow, it's probably caused by some sort of capacity issue, so we need to add capacity. A lot of people think that way in a very symptomatic style. And I'd say that's not the way forward. That's not a sustainable solution. So it's sustainable not just from a environmental point of view, but also from a financial point of view, an operational point of view. That doesn't work. However, when the house is on fire and firefighting is needed, on a short-term basis, you might want to add servers. That could work then. But as the famous poet Notorious B.I.G. once said, more money, more servers, more problems. So let's just forget about that and let's not think about adding capacity. Let's try a different approach. The approach being identify the slowest parts of our application, of our runtime, maybe even, and optimize it. Sensible advice, right? We could live with that, and we can go top-down, bottom-up. If we go top-down, we could say we can optimize the HTML and the CSS and the JavaScript, or your application code sitting behind, or some of the frameworks or framework dependencies. Maybe some operating system components and runtime dependencies, your web server, your database server, literally anything, your network, your data center, you name it. And optimize those elements to get better performance. And I'd say go for it. Very sensible advice right there. However, after a while, you'll hit the point of diminishing returns, meaning the amount of time you invest in making it faster will not continuously yield the same results. You can't optimize your way out of a scalability issue. So you need something more impactful, and that's where we come to the topic of this presentation. I would advise you to use caching technology. Now, I represent a specific kind of caching technology, but from a philosophical point of view, I would say, why would you recompute data if the content doesn't change? Why go through your application runtimes, to your web servers, bootstrap the frameworks, run it, connect to the database, maybe some external API calls, every single time when the data doesn't change? That's the topic of today. And I love to use, when I talk about caching as a way of accelerating, growing, scaling, I love to use the metaphor of the boxes. Because caching is nothing more than storing pre-computed results in boxes for later use. Now that being said, hi everyone, here at the Oslo Spectrum, my name is Thijs. That's how you pronounce that. I'm a Dutch-speaking Belgian. As you've heard in the beginning, I do a little bit of Swedish, just a bit, the kind I learned on Duolingo. And I'm the tech evangelist at a company called Varnish Software. The author of Getting Started with Varnish Cache, an old book I wrote with O'Reilly back in the day, 2016. But I have a new one. Well, new. It's been out since, I guess, 2022, right? And it's called Varnish 6 by Example. I have a free copy here to raffle. It's a big boy, 778 pages, 2 kilos right here for you. And the story behind that is, during the pandemic, I had a lot of time to write, and the lockdowns were longer than I expected. So this is it. I'm not going home with this. I'm going to leave this here, and whoever wants it can grab it. Now, I work for a company called Varnish Software. By show of hands, who has heard of Varnish Software? Great, because if there's one country in the world, on the entire planet, where they should know us, it should be here in Oslo. Because not only are we a company that builds enterprise-grade software content delivery and software acceleration software, we're also the company behind the open source project Varnish Cache, which was founded here in Oslo back in the day. Now, for those of you who don't know the backstory, for the Norwegians out here, who knows Verdensgang VG? VG.no? Well, in fact, this technology was invented by a couple of engineers there because they had scalability issues. So if you follow the timeline, back in the day, in 2005, they came up with that. So what they had was they used Squid, which is a proxy, a forward proxy, started using it as a reverse proxy, didn't yield enough performance. They needed too many servers to get the job done. So they said, a couple of clever engineers they had, let's build something. And they brought on, and I would like to warn you, this is a very Scandinavian story, so we're in Norway, we're in Oslo. They're looking for someone to help them that has the skills to do this, to make something really fast, and who has the kernel capabilities or the inside knowledge of the kernels to make it happen. So they contact a Danish guy named Paul Henning Kamp, and they start a project specifically for Verdensgang, but with the mindset of open sourcing it later on. So that's how it starts. And after a while, it gets so popular. If you look at the stats right there, it's used by about 10 million active websites, 22% of the top 10,000 websites, and that Docker image we have is already downloaded 10 million times. So it's a popular open source project and commercial product, but it became a commercial product because there was so much demand for support. So right here in Oslo, there's a company called Linpro. It's an open source agency. They merged with the Swedish company Red Pill, and out of that came Varnish Software, which is a Swedish company, which makes it, again, very Scandinavian, and that's how it got started. Now, I work on open source, I evangelize open source, however, I also work on the enterprise part, which makes us a company that is well established in the content delivery world, edge compute world. So yes, we make websites faster. That's how I explain it to my mom and my kids. Yes, we make the web faster. We enhance digital experiences by lowering network latency, which is pretty much our CDN play. You can use these caches to make CDNs. And the claim would be that we are a company that builds software-defined web acceleration and content delivery solution. The last thing I'll tell you about us before I start digging in is our claim to fame here is that our software, Varnish Software, again, developed primarily here in Oslo, can handle 1.3 terabits per second on a single machine. And this is software only, running on commercial off-the-shelf hardware, as benchmarked by Intel. They ran it, of course, it's a big stack you need to get it done, but it's commercial off the shelf. I can give you the shopping list, you can buy the hardware, and in a lab situation, you'll have that level of throughput, but also that 1.17 gigabits per second per watt. That's the efficiency levels, and that's what we're going to talk about today. So in a typical scenario, the end user will connect to a server to get a web page, an API, files, video streaming, whatever you use over HTTP, pull in Docker images, you name it. But you know the obvious risk, right? When you do this at scale, well, the server will end up under pressure. Could be because there's too many simultaneous requests to too many clients, or that the payload that needs to be returned is computationally heavy and the server struggles to deliver it. So this is the typical way we would do it. We would install ourselves as a software, hosted wherever you want, as a reverse caching proxy. That's what it looks like under the hood. Meaning that users connect to Varnish. Varnish checks what the user is requesting based on the host header And the request URL looks it up in cache. If it has it, it serves it, which means you don't have to talk to the server, which offloads so much pressure. And if it's not there, well, then you'll request it with the backend, and there will be a single call. So even if tens of thousands of people are going for the same uncached resource, a single request will be sent to the backend. And that's how we make this so powerful. That is the secret, or not so secret sauce. Now, there's a lot of light here in the room, so it's not always easy to see you guys, but I still see a little bit of confusion in your eyes. And for that, I have the perfect solution. So if I want to make this point clear of what a reverse caching proxy like Varnish does, I always throw in this one. So who knows this movie? Who's old enough to have seen this movie? By show of hands. Okay, what is it? What movie is it? You could shout it out. There's a little bit of a gap here. What are we looking at? The Bodyguard. The Bodyguard is a movie featuring Kevin Costner, Whitney Houston, and the storyline is that we have a very talented singer and actress, like someone in the entertainment business, who's super popular and in the end needs a bodyguard to protect her from all the stalky fans. And that's maybe the perfect way of talking about reverse caching proxies. When in doubt, your application, that's Whitney, and Kevin is the cache. So keep that in mind. Now, there's different kinds of caching, and if you look at computer systems, it's caching all the way down. However, we'll be talking about HTTP caching, and HTTP, as a protocol, has built-in caching mechanisms that are part of the protocol that nearly all the HTTP caches respect. So if we look at this one, it should be very straightforward, right? You've seen this, a cache control header with a public max h equals 500, meaning that this will be cached for 500 seconds. However, it gets a bit more tricky. There's a lot more syntax than what you'd expect. So in this case, we're having a max age of 500 and an S max age of 1,000. Anyone want to take a wild guess how long the cache, and with the cache I mean the reverse caching proxy, will store this? Any takers? I see you thinking. Well, the answer to the question is 1,000. Because the S max H, so S max H stands for shared max H, is a specific directive that was invented for caches. While Varnish, if we go back, will respect the 500, and a lot of caches will respect the 500, if we see both, we will cache the object for 1,000 seconds, in this case, and forward the rest to the browser. And the browser can then choose to cache it for 500 seconds. However, if you don't want to cache, you can throw something like this into the mix. So these are headers that you, as an application developer, can send to any type of cache or to the browser to make sure that these things are cached. So in this case, we don't want to cache, and it's a combination of private, no cache, and no store. And they mean different things. Private means you can cache it, but only private caches, like a browser, because maybe the cache is unique to you, or the content is unique to you, so you don't want to mix it up with other people, you don't want to share it. No cache, you would think it means you can't cache, but ironically, it means you can store it in the cache, but you can't serve it from the cache without proper revalidation, meaning the server, Varnish, still has to connect to your origin. And then no store means don't store it in the cache. And there's more headers, like a vary header, which creates cache variations, based on maybe you're sitting behind a load balancer that does your TLS proxying, so maybe you want to forward to your original proxy over an exported proto header. Or maybe you want to create a cache variation on the browser language. And allow me to explain how that works. So let's say the user connects to Varnish, gets the homepage of a website called example.com, and the browser takes the liberty of forwarding the supported languages. And in this case, the accept language header of the browser is English. So Varnish will take that on, it doesn't find it in the cache, it forwards it to the server itself, and the server looks at it and says, hey, great, I have that content, and it returns the content with a caching header, 500 seconds. However, it also indicates that the content is in English, and that we do want to have a cache variation based on the language. Varnish understands that vary header, and will create several variations for every language. So initially, that user coming in will create a hash in the cache to look it up, which uses the host header, the URL, but also that exact language, English. So that means there's a separate one on the homepage for English, and I'm a Dutch native speaker, so I will come in with my accept language NL, and I will be sent to a different element. So vary, if we go back, vary accept language allows you to take a request header, which is called accept language, and use that to create different variations. And that's a way of improving something that would otherwise not be cacheable. And the last one we'll throw in is, again, max age 500, but with a stale while revalidate equal to 200. Meaning that if the cache expires after, let's say, 500 seconds, 200 seconds beyond the expiration of the object, you can still serve the old stuff. But meanwhile, we will do an asynchronous fetch with the origin to get the updated version. Meaning that no one is really the victim, no client is the victim of being the last one to hit the object before it expires. You don't have to wait, because we keep serving you the old stuff, doing it super fast while we get the new one in. So all part of the HTTP spec, of the HTTP caching standard, and it doesn't come as a surprise that we as an open source project adhere to these conventions. However, this is all fun and games for very static stuff. Static HTML, images, CSS, JavaScript, video files, everything that is static. However, things get a bit more tricky when cookies are involved. Because cookies are a way of setting state and are highly personalized. And Varnish, out of the box, when it sees a cookie as part of the request header, it will decide not to cache, which is quite severe of a decision. It also doesn't cache when it sees an authorization header coming in, because that also means it's highly personalized. Things don't get cached because the content is for your eyes only. And that is not a shortcoming, that's by design, because we'd rather be defensive and conservative, and because there's only one thing more dangerous than not caching enough, and that's caching for too long. And there's a ton of horror stories. A famous one is some sort of system where tax returns are stored, and the tax return was cached. So someone logged in and saw someone else's cached version of the tax return, and that caused all sorts of drama. I've seen it myself with setting too aggressive caching back in my previous job, being able to store the contents of a shopping cart, meaning everyone saw the same shopping cart. So you do not want to get into that. If you see a cookie or an authorization header, you are not going to cache, which grinds this entire presentation to a screeching halt. What are we doing here? What are you doing here? Why did you choose to come here? What do you want to learn? Because I'm going to make a statement, I'm going to ask you a question, and we're going to come to a conclusion. So the statement, and I'll repeat it again, Varnish, out of the box, does not cache when cookies are present. That's a statement. Here's my question to you. Do you know a modern-day website that doesn't use cookies? Right? Everything uses cookies. So is the obvious conclusion then that Varnish cannot be used in the real world? One would think that's the case. But of course, I wouldn't be wasting your time and my own time being here. So what I can say is, while this is the standard behavior, and very much a conservative behavior that makes sense, you can extend that behavior. And what you could do is use the built-in programming language and extend that standard behavior in an opinionated way. And this is what caching the uncacheable is mostly like. So that Varnish configuration language, or VCL as we call it, has capabilities that are specific to the project. Meaning you can do request handling, you can reroute requests, you can rewrite them, you can change them, the responses and manipulate the body, you could select which backend you're connecting to, you can control every aspect of the caching, where to cache, what to cache, how long, how to revalidate, how to do variations, all of that stuff. And you can make your decisions on the edge. And the edge is an important term here. The edge is a definition that means the outer tier of your web platform. And that's typically the part that talks to the end users. It could be a cache like what we offer, it could be a CDN, could be whatever. So thanks to that language, which is a domain-specific language, that has a curly braces style similar to C and other languages, you can write behavior, and when Varnish starts, it will read the file, it will transpile it into C code, compile that C code into machine code, and share it or link it to the runtime process as a shared object. So it is super fast. It is not a top-down programming language, so you're not forced into writing everything yourself. As mentioned, there's a standard behavior, and that standard behavior and the flow is expressed through a finite state machine that you can hook into. So if I were to do a Varnish training, I would spend at least a half an hour on this, but we don't have that type of time. So you know how to read flow charts, I guess. So the square boxes or the rectangular boxes are the states that you can end up in. The states that are overridable have a prefix called VCL, meaning you can extend them in VCL, and then after the underscore, there's the context. So it all starts with start, and then you enter in VCL recv, which is short for receive. So that means you receive the request. You make your decisions, maybe you extend it, we'll see that in a minute, and then you decide what the next thing is. So you do a return statement, and you end up on the next one. So let's take a cache hit, which is the optimal scenario for a minute. So follow the green lines is what I would say. We start with receiving the request. If we deem the request cacheable, we will create a hash. That hash contains the host header and the URL. We look it up. If we find it in VCL hash, we will go to VCL hit, meaning we have the object we want to return. We don't need to talk to the backend. We end up in VCL deliver, where we deliver the content, and it ends. Now, of course, could be in a situation where you have a cache miss. A miss because the content wasn't in the cache in the first place, or because it was in the cache, but it was outdated, expired. Well, then we have to follow the blue lines. We'll do the same. We'll hash. We'll look it up. We'll conclude that it's either expired or not in the cache at all, so we'll enter VCL miss. And then we have to go to that big gray box, which means connecting to the server. That's what we tried to reduce as much as possible for the sake of performance. And then there's a bunch of statements there, like backend fetch, meaning you prepare an HTTP request that you'll send to your server, and when the server responds, prior to storing it in the memory of the cache, you'll reach VCL backend response. And there's so many others. Let's make this very practical. Here's a VCL example. Here's a very simple VCL example that uses an extract that is used in a lot of WordPress websites. First things first, we connect to the backend, named default, and as it happens, it's hosted on the same machine, on the local host, the loopback interface on port 8080. We will expose ourselves on port 80. So we hook into VCL receive, and we do an introspection of the request URL. And we see that if the request URL matches, and that's the keyword here, matches, you see the tilde operator, that means match a regular expression. So if it matches /admin or /admin/ or /admin/ and a subordinate resource, you're pretty much in the admin panel. We do not want to cache it. So we do a return pass. That's what happens here. We go to pass. Pass is different than miss. Pass means you will bypass the cache at all times. It'll never be stored in cache. That's that one. And under all other circumstances, if the content is cacheable, we'll just strip off the cookie and proceed. So that's one of the ways of doing it. Another way of doing it, another use case would be to manipulate the time to live and the caching headers. So what you would do in this case is enter VCL backend response, which is here, meaning something was missed or bypassed, so we need to connect to the backend, and the backend has responded. And if the backend responds, we'll use the backend response object, bresp. We'll look at its HTTP headers and check the content type header. If the content type matches image / or video /, obviously, we have a video, we have an image. So that's very static. So we're going to bump the TTL to a year. We're going to store it as long as we can. And we'll expose a really long max H header, which Google likes, by the way, to the client. And the browser can choose to store it also for a long amount of time. Any other logic will bypass and will immediately deliver. However, if the content is HTML content, identified by a content type text HTML, or it's JSON, with application JSON, then we'll decide to cache for an hour, bypassing any type of cache control header that was sent by the origin. That's where we end up here. And another example here, which is a very noisy, busy example, is where we try to optimize the request URL. Because again, URL is used to identify the object in the cache. So the first thing we're doing, and the comment really hints towards it, is we're going to alphabetically sort the query string parameters. Let's say you have a web page that has the parameters ID equals 1 and category equals 2. If you reverse their order, you have another string, you have a cache miss. So we're sorting them alphabetically in terms of content sanitation. Then the next thing we'll do is we'll strip off all those tracking URL parameters, those campaign parameters that you see in all the newsletters or on the landing pages. They're Google Analytics specific, the server doesn't need them, and it messes with your hit rate. So we just strip them all off using regular expressions. We also strip off potential hashes that end up, these HTML anchors that allow you to navigate to the page. And if your URL ends with a question mark, that means you're planning to add URL parameters, but you didn't, so we'll strip that off as well. This is logic that happens in VCL receive. So those are a couple of basic examples. Let's move into the world of the more or less uncacheable. So let's look at cookies, because cookies are a big deal. I told you that cookies aren't cached by default. And you saw how I dealt with it with the admin panel. I was very adamant that everything within the /admin/ is uncacheable. Let's not deal with it and then strip cookies off. Here's another alternative. Let's look at the type of cookie we have and then make the decision. So here's an old school way of doing it in Varnish, is remove every single cookie, because most of them are tracking cookies used by Google Analytics and what have you, so we don't need them server side. However, let's keep the session ID. If we see a session cookie, that probably means someone logged in into a panel and it's highly personalized. So that way, we're stripping everything off except the PHP session ID. I use PHP here. I come from the PHP community. It still has a very warm place in my heart. I guess a lot of you are .NET people. I'm not sure. But you get the idea, right? You have a session cookie. You strip it off. Here's the more modern way of doing it. We have a module that you need to import called cookie. And then you can say, parse the cookie from the cookie header. Only keep the session ID and rewrite it. And if in the end, the cookie is nothing but a set of white spaces, just strip it off. That's another way of doing it. Now, I don't want to give you the impression that cookies are bad. You can also take the value of the cookie and use it to your advantage. So here's the ugly way. Again, reg sub, a lot of regular expressions. Let's immediately move to the clean way, using the module. So imagine that you have a multilingual website and you don't use the accept language header that the browser exposes to create the multilingual content. You use the old school, good old splash pages. You land up on the splash page, you have to select your region or your language, and the minute you save it, it will set the cookie and will use the language cookie for that. And your web application is built for that. But remember, if we don't include that awareness, it's first come, first served. So me as a Dutch speaker, I would go to the website, get my content in Dutch, it will end up in the cache, and you as Norwegian speakers would see Dutch content, which would make no sense. So you need to use the language cookie in it. You need to cache the uncacheable, if you will. So what I'll do is I'll strip off all the cookies except the language cookie, which you can see in the if statement. Write it back, strip it off if the cookie is a collection of empty white space characters, and then explicitly return hash, which bypasses any standard behavior. We're going to say, regardless of the fact that we have a cookie, we'll still decide to cache. And then we'll create the hash. The hash, by default, uses, I've mentioned it a couple of times, the host header, so example.com, if you will, and the URL. And in VCL hash, where we'll hook in, we'll extend that, and we'll add the language value as well. So we're going to look at the cookie, and if the cookie has languages like Dutch, French, or German, then we're going to extract that value, we're going to do cookie get, and hash it in. And for all other purposes, we'll use English as the language. And that way, you have multilingual support in your cache without having to use accept languages and those kinds of variations. So here's a diagram of how you could go about. So I'm coming in with a language cookie English, and the system says, hey, no problem, we have it, here's the value, cache it for 500 seconds, and we'll be clever enough to extract English and to store it there. If I come back in with a Dutch cookie, we'll take the other one. I did add a couple of precautions in the if statement in the VCL hash to ensure that we don't support every language. Like if you're clever enough and you start manipulating the cookies and setting it to Spanish or to whatever other language you have, to Danish, God forbid, right? Then you would create so many variations that things would spin out of control and your hit rate would drop. So that's the backup. Only support the languages that are supported in the application itself, fall back to English for all the rest. So that's that. And comes with the good, comes with the bad. The bad being, imagine this. You use the cookies, you decide what you can cache, what you cannot cache. But let's say 99% of a web page is cacheable. But you have that really annoying header at the top with either the shopping cart information or your welcome Thijs, welcome John, welcome whoever. It's being served over a single HTTP response, so we have to find the common denominator in terms of cacheability. And unfortunately, that means we can't cache. It's impossible because one tiny fraction of the content was highly personalized. Tough luck. Luckily, us web developers, us web people have found a placeholder technology to help us with that, and to separate the cacheable from the non-cacheable content, and to ensure that your output might be a composition of multiple requests happening. Now, obviously, we're talking about initially how we've done this in the past, technology like AJAX you could use, right? You just say, hey, dear browser, I want this piece of content to come from that URL, pick it up, There's probably a no cache header attached to it. It probably uses the cookie. It probably goes to the session store. It probably gets all those values. However, I'm not a huge fan of it because you're turning your server problems into the client's problem. Because what you're basically doing is saying, hey, dear client, go send that extra round trip. I don't care. I don't want to deal with this. Which is not really kind, right? And it's an extra round trip. On slow connections, you're really burdening the client with it. And it's a JavaScript thing, so if something goes wrong in the JavaScript, you as an operator from the server side have zero control. Luckily, there's an alternative called edge side includes. Who's heard of edge side includes? By show of hands. Bunch of people. Nice, nice. Not bad. Well, for those of you who don't know it and who are of a certain age, I would say, a certain level of maturity, I would say, do you remember server side includes? From the good old days, or the bad old days, depending on how you want to look at it. These were the good old server-side includes. You could drop this into your HTML, and your server, your Apache would parse this, would read the file. This is server-side includes, parsing happening on the server. Edge-side includes, like these bad boys here, can be parsed on the edge. And I already mentioned, the edge is the outer tier of your web platform. So pretty much Varnish would parse these. And Varnish would look at them, look at the source attribute, and load that as a sub-request. Meaning that you've pretty much built a placeholder technology parsed by Varnish. The output is a composition of blocks, and every endpoint that is stored in the cache has a separate state, a separate TTL, which is very beneficial because that annoying little welcome John widget at the top could be parsed on the edge and could be not cached, whereas 99% of the page can be cached. And the way you would enable that in Varnish is by enabling bresp.doESI. Set it to true, and you're done with that. But it's a bit more than that. You don't want parsing to happen on every single page. Maybe you want to do that conditionally. Maybe some pages don't use it. Maybe you don't want to waste too many CPU cycles. My tip to you, my advice would be, let's do some ESI negotiation. Now, mind you, ESI is not something we invented. This is a standard. It was invented by, I think, the lovely people at Akamai, who are a big CDN. CDN is nothing more than caches like ours, but geographically distributed. So there's consensus over this type of technology, and multiple technologies support it. The way I would advise you to do it is by leveraging HTTP headers and just sending, that's what we would do, send a surrogate capability header to the application by saying, hey, dear application, we're not really a client, we're actually a cache, and we have support for ESI. So if you have those capabilities, go ahead and take control. And the application would respond. So this is a request header being sent to the application. If you spot that, and many frameworks have the capabilities of spotting that, you'll say, nice, so you have surrogate capabilities, I'll take surrogate control. And it will return that response header, and that's the trigger for Varnish to say, let's do some ESI parsing. And this is the VCL that does this. So in BCL backend fetch, we're preparing an additional request header. We're saying, hey, we have the capabilities. ESI is one of those capabilities. And on the other hand, we'll be listening to what comes back. So if the server responds with a surrogate control header that contains ESI, we'll do the parsing and strip off the header. Which means you could write stuff like this and do composition of blocks in your view layer. This isn't necessarily something you should do in your control layer. You say, hey, ESI, and some frameworks even have wrappers around it that do the surrogate capability, surrogate control check. And if there's not the right surrogate capability, it will just do the internal rendering at the server side rather than sending this to the edge. So you could use something like this with header, and that could be replaced by Thijs. If you want me as a consumer in my browser, I would see this, but behind the scenes, this will happen, and my homepage will be cached separately, maybe for an hour, maybe for a day, and that header widget would not be cached at all. All right, let's pause it for a second and do a status update. We're half an hour in, exactly where I want it you to be, and let's see what we've done and what we've learned so far. We've learned that cookies are a bit tricky, so is authentication, because it's highly personalized. And typically, you don't want to cache it. However, we've already leveraged VCL to decide what to cache, what not to cache based on the content of the cookies, but also to leverage cookies for certain cache variations. Cache variations are multiple copies of the same page with a different variation. I'll also show you that you have to be careful with those variations because too many variations of an object will yield too many misses at the origin level, so balance it out. And we've also learned that we can use placeholder technology to separate stateful from non-stateful content. But there's a lesson here, and the lesson is that even though we've done a good job and really improved the performance of our application, I could comfortably say that we've went times 10 in terms of performance, or times 100, depending on the situation. We still have those non-cacheable routes, which will be consumed at an equal pace. And those tend to be a target for high server load if whatever it takes to compose that is computationally heavy enough, or if you have enough requests coming in. It could also lead to latency for loading the page. So let's switch gears, switch mindset, and say instead of just storing all that stuff in the cache and just serve it, why don't we use that VCL language and the capabilities of it to do more computational stuff? Like, why, instead of saying we won't cache it, we could say, hey, you know what, we'll compute it. We'll see what the data is. I'll give you a very simple example of loading authentication. This is the stupidest example you can use in terms of authentication. So we know probably basic auth, and there's even a typo in this slide. It should be basic space. It's an authorization header. We check it, and we see if that is the base64 encoded value. Now, if you would base64 decode it, it's username : password. So that's how basic auth works. So we could say, hey, if that value doesn't apply, go away. Return 401. So we're synthetically returning a response saying, go away, authenticate. And in VCL synt, which is the synthetic placeholder, we could just say, if the response is 401, add an additional header, www authenticate, and that would trigger that server-side pop-up in your website. That's how these server-side pop-ups work. That's the HTTP behind it. There must be an authorization header. It must be the right one. If it's not there, we'll trigger that by doing authenticate. There's more secure ways of doing that, of course, by using a module that you can import and read the HT_passwd file that you could use in your Apaches of this world. You can also store hashed versions of the password so that you're not exposing the real ones, and read it from there. That's one way of doing it. Now, there's different kinds of authentication, of course. When I look at you, I see you ask the question, hey, what about JSON Web Tokens? It's quite popular as well. Who's familiar with JWT? By show of hands, just to read the room a bit, so I don't. Then I could skip over this quicker than I anticipated. Here's a JSON Web Token. For your convenience, I color-coded it, meaning that this token that could be transported in an authorization header, even in a cookie, if you will, is a collection of 3 parts separated by dots. Each of these parts is base64 encoded JSON. The first part in red is the header. The middle part in pink is the actual payload you're transmitting. And the blue part is the signature, which is somewhat secure, or is secure, because it is an HMAC with a secret key of the concatenation of the header and the payload, meaning that if someone would tamper with the data to do privilege escalation or something like that, the hash would match. You're pretty secure. So if we would decode that, because again, this is nothing more than base64 encoded JSON. If we do a base64 decode, this is what we end up with. The header says that we're securing this with an HMAC signature using the SHA-256 algorithm. The type of token we're having here is a JSON Web Token. Then we have the payload, which has a subject, sub, a name, an IAT, which means issue that, which is a Unix timestamp, and then the expiration date, which is also a Unix timestamp. Naturally, we're trying to keep things as short as possible because this needs to go over the wire. The bigger your tokens, the more data you consume. And in the end, we do the HMAC signature that has the secret. Now, from an authentication perspective, that will typically be sent using a bearer authentication token in APIs. It's pretty common. I'd like to warn you, and I'd like to make sure you're well seated for some really ugly VCL code, but functional code that you can use in open source for a lack of a module right now. Ready, set, go. I'm going to have to guide you to there. There's going to be some hand-holding required, I guess, to work through this, because it uses a lot of really ugly regular expressions. It does string replacements. So let's start. We're entering VCL receive. So we're receiving a request, and we're looking for an authorization header sent by an API, for example. If that doesn't match bearer and then the token, and the token is a collection of at least 3 non-dot characters, collection of those separated by dots. If that's not the case, we'll just say forbidden, you're not allowed in here, JSON Web Token required. That's the start. We're already offloading that. Again, why are we doing this? To ensure that the origin doesn't have to do that your application doesn't have to do that, and that we don't have cache misses. So by tackling this, You're pretty much ensuring that authentication gateway is set up at the front, highly performant, and that the application can cache. So we've stepped past that. Next step is, let's see the first bit. So we're setting the JWT header, and we're extracting it from the first group using \1. So that's the first one. In that value, there is probably a type property in JSON and a ALG property. We're going to use the digest module and base64 URL decode that to turn it into actual string data JSON. We'll take the type, we'll take the algorithm. If the type is not JWT and the algorithm is not HS256, then token's invalid. Return, stop whatever you're doing. If it is a valid value rather, we're going to extract the payload, which is the second group, as you see in the last line on this slide. So we already have the payload. The nightmare continues in terms of ugly VCL code. We have the payload, we need the signature now. So we're going to get the third group, which consists of the signature. And then we're going to compute what we expect in terms of signature, because whatever we get might not be the right signature, it might be tampered with. We know that a real signature is the header, the payload, brought together with an HMAC signature and a secret key. The secret is secret. Unfortunately, that's the second line. JWT cur sig, that's the current signature. How do we compose it? Well, we take the header, a dot, the payload, a dot, we HMAC it with SHA-256, encode it with base64 URL notepad hex, and that is that value. And that value needs to match. So if the signature we've got doesn't match our current signature, someone has been messing with your JSON Web Token, and we don't want to support it. So in that case, 403 token JWT invalid token signature. Once we get past that, we know we have a valid token. It has been validated, so let's extract some data from it and use it to our benefit. So the payload, we take it from the raw payload, again do a URL decode. And from there, we might want to know the expiration time, and we want to know the username. So we extract that, and then we can continue. And the last check we'll do is to check whether or not the token has expired. So all of this can be done on the edge without bothering your application, without wasting precious CPU cycles, precious memory. It's a good thing. And then you can strip off the authorization header and go back to standard behavior. Now, of course, there's an easier way of doing this. We even offer a module in our enterprise product that does exactly the same, like this. Easy, right? So a couple of lines, module, check it. The thing with the secret is, I call the secret key secret. I would advise you to choose a different value, maybe read it from disk, maybe roll it over and have new values every now and then. Just remember, the only two parties in this chain that know the secret are the one who creates the JWT and the one that validates it. So make sure it is secured. All right, let's step it up a notch. We can do authentication management and do an authentication gateway. We can also start returning our own responses if we will, and we will leverage synthetic HTTP for that. So you've seen the return synth throughout a couple of examples. Synthetic HTTP means HTTP responses that are returned that did not originate from the origin server. We created it ourselves. So if you would do this, it would return 200, and it would use the standard reason phrase, which is obviously OK. I'm not going to play that game where you are asked, what's the standard reason phrase of 200? It's 200 OK. We're going to deal with that. However, we can extend it. We can add a string and say 200 hello world instead of 200 OK. So all of a sudden, we start responding in ways we choose without depending and without connecting to the origin server. That's where we end up in VCL synth. So if you go from receive and we do a return synth, you'll end up in VCL synth, which is the response that will be returned. Unfortunately, there's a standard template that looks like this. So whatever you return will be parsed in a string and a template like this. So if you ever see Guru Meditation on a page, just know someone is probably using Varnish. However, you could change that template. Here we're turning it into plain text without any additional templating around it. You can turn it into JSON. The fact of the matter is that we'll use this to return very personalized data via synthetic responses. Here's where you need to pay attention. So imagine having this /API/session endpoint that uses either a bearer authentication token or just a simple session cookie for all you care. That is typically uncacheable. But what we can do is intercept that request and start connecting to the session store ourselves, fetching that data to ensure that this data that is uniquely specific for that user, we know whether or not they're logged in and how many items they have in the cart. That JSON output could be generated by Varnish itself if, for example, we connect to the session store that could happen to be Redis. There is a module that's contributed by a guy named Carlos Abalde, friend of the company. He doesn't work with us, but we work with him sometimes, and he created this module that you can connect to it yourself. And let's say your application uses this structure. This is Redis. This has nothing to do with Varnish. You can log into Redis, and you can check if that session key exists in the session store. It's your application that writes to the session store. This is a distributed session store. You can have multiple servers in your setup. They all connect to that cluster. So does it exist? If it returns 1, then the session exists. You know that much. And then you can do an HMGet, which means hash multi-get. You store the hash with multiple properties in that database. It might have multiple properties that you want to fetch. So we want to fetch the logged in property and the items in cart property, which returns true. Yes, the user is logged in with that session, and there's 5 items in the cart. And that brings us eventually down to the VCL code that we can use, where we can, at startup time, open a connection to Redis, intercept in VCL receive the /API/session endpoint, which would typically be handled by your application, but you're doing it yourself. We'll parse the cookie, we look for the session ID, and if it's not set, hey, you're not allowed in here. This is personal, go away, 403. If it is, we're gonna take that cookie, set it as a custom request header, and return a synthetic 200. Remember, synthetic content ends up in VCL synth. So all the magic actually happens in VCL synth. So what we can do is, again, intercept API session, connect to Redis, check whether the session exists. We'll already assume that whatever response we return is a JSON response, so we'll set the content type. If the answer is 0, that means the session does not exist. So you do a 404, or a 403, or whatever you want to do. Then when you get past that, you can actually do an HMGet, which you saw right here, right? You can do that. Ask for the logged in status, ask for the items in cart, create a synthetic response body, and just return whatever came back. And remember, this value that you used to identify, you extracted it either from, I did it using a session ID. It could be a JSON web token for all I care. And that's how you get highly personalized data on the edge without using any of the application logic and doing it on the edge. Is my message here replace your application code with this type of stuff? No, absolutely not. But choose your battles. You could have specific items that have a very high pressure on your system, and by using simple logic like this, if the business logic is that simple at your end, just put it there. There's a lot more we can do in Varnish Enterprise. This is not a pitch for Varnish Enterprise, but I just wanted to show one module that we have that is kind of interesting. That is edge stash, which is mustache parsing on the edge. So that means you could use that type of syntax and have a template, maybe a page that is cacheable, but the username, you would just add the handlebars with username. And we would talk to a JSON endpoint, parse that, and give you the output. So here's a little bit of out-of-context VCL, where we parse API session, which you saw earlier, right? You saw that. And parse the home page for edge stash templates, and at delivery time, just inject the endpoint and go for it. It's a fun bit. It's more flexible than ESI. It's not open source, unfortunately. Just wanted to show that it is around. And we can use another module that even if your application does not support these handlebars, you can inject them and do a find and replace. So this code, and let's not focus too much on the code itself, but rather on the use case. Let's say my website doesn't support the templating and just emits Thijs as the username. I could do a find and replace and turn that into a handlebar on the edge without touching the application code. Yes, tons more stuff we can do there. A lot of exciting modules. If you want to know more about it, you could talk to us about it. We even have a control plane to manage it, all that kind of jazz. That's not something we'll talk about now. If you're interested, talk to me. What I do want to mention is that you can run this stuff anywhere you want. So you can run it on-prem hardware, as long as it runs Linux, it's fine. You can run it in the cloud. You can run it in Docker, even in Kubernetes. So my advice is, if you want to play around with this open source technology, use our official packages if you want to install it on your own servers. Go to packagecloud.io, Varnish Cache. You'll find Debian and RPM packages. We are packaged, even our enterprise stuff is packaged on AWS, Azure, GCP, and Oracle marketplaces, meaning if you have an existing relationship with those companies and they know your credit card details, you can even use our enterprise software with a lot of extra bells and whistles without having to do upfront payments. If you want to use the free Docker image, which has been downloaded more than 10 million times, you'll find the details on the Docker Hub. But it's as simple as doing a Docker pull, Varnish latest and Varnish stable. There's 2 variations. Latest means twice a year on March 15th, September 15th, we have a new release that is managed by the community and where we as a company have little say in. It's the community's project. We assign resources to it for development, but they do it. And there could be incompatibility. That's whatever is latest. However, we provide an LTS version as our contribution where we backport features. So if you want the LTS, you just do Docker pull, Varnish stable. And it's as simple as just running it, mounting the VCL file in it, and maybe use an environment variable to set up the size, and go for it. Now, one of my colleagues also ensured that a lot of extra modules, some of which were featured in this presentation, are also added. So if you use Docker, you don't have to compile them yourself, but there is an initiative that I'm part of to do more packaging and to ensure that you can use it via Debian or RPM packages. And if you're running Docker images in Kubernetes, you can use our official Helm chart, which was released a couple of weeks ago, where you could just do Helm install, run the Helm chart, and the values.yaml file that are configurable, that's the minimum, right? Your VCL, maybe expose it as a service with node port, and be done with it. That could be it. Now, I'm about to end. I'm ready to end. We have 10 minutes left. And I would like to talk about the future that is even more exciting than what I showed you now. So what I showed you is a language called VCL, which is very domain specific, and is not out there in the wild. You probably don't do a lot with VCL. However, we have a research project that is taking a decent shape, where I'm seeing a lot of progress this year, that allows you to run WebAssembly on the edge. So WebAssembly being a compilation target, here's some stupid WAT code, which is the textual version of WASM. WASM is an instruction set. A lot of languages have a compile target for it. So these WebAssembly files, you could basically run them on the edge. And we have a project to do that. So whether you're writing it in C, or you're doing it in Go, or in Rust, or in JavaScript, as long as the output is a WASM file, and you respect a couple of APIs that we provide you, some WASI interfaces, you can run it. So no need for everything VCL. So that's a transition we're making in our mindset, not specifically from the open source community, but for us as a company, is we want to go low code, no code, or different types of code. We want to give developers the freedom to do it whichever way they want. And the project name is Project Sledgehammer. Hammer because it's powerful, you can hit things with it, but edge, sledge, well, the edge part speaks for itself, right? I can show you a little bit of code, but it's still all in flux. So our developers pretty much asked me to add this disclaimer that everything you're seeing is very experimental and likely to change. So what you could do is, in your VCL, you could bootstrap a folder where your WASM file is and some rollup config, and just run it. And you're no longer bound by VCL and the capabilities of the language. Because again, the language has its limitations as well. You can only go so far. So here's some, I replaced ugly VCL code with ugly JavaScript code. Why? Because I'm not really that good at JavaScript. But what this pretty much does is, it does authorization as well. It checks, it sets a JWT in JavaScript. And even if you don't like the code, and even if you don't read the code, just remember, you can import NPM packages, you compile it, and we'll take it from there. We'll take the WASM file that contains everything, maybe some additional rollup config that you pass to us, and we'll just run it on the edge. So this will check the endpoint, we'll do basic authentication. If the username and password match, we'll set a JWT, and we'll continue on with it. And what we will then do is, we'll take the value of that JSON web token and do a find and replace in the output prior to storing it in cache, using some DOM logic, and store it in there. So, long story short, or very long story short, we're working on something that supports WASM so that you can express yourself in the language you feel comfortable with. And a lot of languages now support WASM as a compilation target. We'll respect that instruction set. We'll run it in different shapes and flavors. And in the future, Sledgehammer will be even more important to us. It's developed by us, not by the community, but it is our intention to open source it, provide it to the community, and build an open platform for edge logic. We'll also improve our productization on the marketplaces. So if you want to run stuff with open source or enterprise or whatever we build as an intermediary product on AWS, on Azure, GCP, Oracle, and other marketplaces, we'll put a strong emphasis on that so that you can do more on the edge. We'll try to be a first-class citizen in the cloud-native ecosystem, doing more with Kubernetes. One of the plans is even to create a Varnish-based ingress controller or gateway to ensure that the caching happens in front of the cluster rather than running it with Docker images on the side. Packaging more modules so you have more ways of expressing edge logic. And finally, maybe improve the Varnish configuration language and add more features. Ladies and gentlemen, we've reached that limit. We've reached that point where we can comfortably end it. I know there was a lot of information in there. Last thing I need to do is I need to give you this book if anyone wants it. A lot of the stuff I talked about is in there. Even the basics are in there. Everything about HTTP caching. So if you're interested, I'm just going to put that here. I'm going to walk off stage in a second, and if it's gone, it is gone. That being said, thank you for sticking around. Tack så mycket. Again, I don't speak Norwegian, so I'll do it in Swedish. Thanks a lot. It was an absolute pleasure. I know you have options. I know there's a bunch of parallel sessions. You chose to be with me. I fully appreciate that, and I'll see you next time. And of course, questions, we'll do that on a more personal note, right? No one wants to hear each other's questions. So if you have questions, show up. I'll try to answer them.